In this video, we'll be discussing the AutoCAD coordinate system. If you'd like to follow along with this video, please open the file, the AutoCAD coordinate system.dwg, located in the Working Files folder as discussed in the Working with this dataset video. When you create 2D drawings, you create geometry on the XY plane. In many cases, the only time you give the coordinate system any thought is when you're entering an absolute or relative point. As you create geometry in 3D, you will need to reorient the coordinate system to create and modify the geometry as needed. Let's talk about the basics of the Cartesian coordinate system and how it can help you create 3D designs. In the following drawing, I have 4 viewports open. Each of the viewports shows the different planes as defined by the Cartesian coordinate system and the X, Y, and Z axes of the Cartesian coordinate system. The UCS icon is shown in different modes based on the visual style of the viewport. Notice that in the top, left, and front viewports, the UCS icon is showing as lines because this is set to a wireframe visual style. In the isometric view, it's set to an X-ray visual style, and you'll notice that the axes are showing shaded. So what's the definition of the Cartesian coordinate system? Well, hopefully you've all taken some basic geometry classes, but computer-aided drafting and design systems base their positioning of points in 3D space on the Cartesian coordinate system. The Cartesian coordinate system is composed of 3 axes, X, Y, and Z, and they are at 90 degrees to each other. These intersecting axes define the origin point for the coordinate system and 3 flat planes. The origin point is the location where each axis value is 0. The 3 planes are defined by pairs of axes which create the XY, as you can see here in the top view, the XZ, as you can see here in the front view, and the YZ, as you can see here defined in the left view. This is an isometric view and is shaded with the X-ray visual style and just shows you an isometric view of all 3 planes. So there is one preset coordinate system that you cannot change. This coordinate system is referred to as the World Coordinate System, or WCS. If you notice in the top view, in the view cube under the coordinate system section, this view is set to WCS. When you begin to create 3D models, you will find working only from the WCS to be challenging at times. To make it easier to create and modify geometry, you can define a user coordinate system, or UCS, at any place or orientation in space, and you can define as many as you need. When you define a new UCS, you define a new origin location and direction for the X, Y, and Z axes. The way you define a new coordinate system depends on the geometry you have created and the geometry you are trying to create and modify. In some cases, you will have the coordinate system automatically change based on a flat face you hover your cursor over. In other cases, you will manually reorient and reposition the coordinate system. This manual adjustment can be as simple as moving the origin to a new location, reorienting it by picking 3 points in space, or rotating its alignment around one axis. By default, the drawing displays an icon to help you visualize the orientation of the current coordinate system and its origin location. This default icon labels the X, Y, and Z axes and color codes them. If we look at the isometric view here, the X-axis is red, the Y-axis is green, and the Z-axis is blue. You'll notice that in each of the different views, I have a different UCS defined. Notice how even though this is the YZ plane, the UCS is actually defined right to that plane, as you can see here by the X and Y orientation. Same thing with the front view. Even though this is the XZ plane, you'll see that the UCS icon is showing XY in there. So if I begin drafting in any one of these planes, the objects will fall on that actual plane. So let's just do a quick little demonstration of this by going to the Draw panel, Rectangle tool, and in the front view, I'm going to just draw a rectangle anywhere, and notice in the different views how the object actually appears when I click in there. So notice in the top view, it shows it as it should, right? Because the UCS was defined in the front view, so we're looking straight down on it. In the left view, you can see a little tiny line going this way, and of course, in the isometric view, you can see how that rectangle was drawn. If I draw it in this view, this should be on the left side, and so now notice how in the front view, it draws it straight into it, and in the top view, it draws it on the left side, as you can see, like so.